Hi everyone, welcome back to Dubious Engineering. Some time ago, Big Clive went to Poundland and he found these. These are portable power banks, and they're £1 and they have a 1200 amp hour lithium ion cell in them. So I thought, well, you know, for £1, the charge circuit alone is quite cool. Maybe we can upgrade this. Out came my 3D printer, I busted apart an old laptop battery, and let's see what happens next. So we're disassembling a lithium-ion pack for a Samsung laptop, and inside that lithium-ion pack are a whole bunch of Samsung batteries and some Samsung battery management equipment. What we've got here is a 3D printed enclosure that I designed myself. So the 3D printed case should accommodate 4 lithium-ion cells, as you can see right there. And what we're going to do is wire all those bad boys in parallel. So, word of warning, these power banks made by Signarex that we got from the pound shop charge most USB devices and MP3 players and phones. They don't work with iPhones. Well, they'll work with the iPhone 6 and lower, but the iPhone 8 and 10, they won't work with those. But anyway, they're cool little battery banks. 1200 milliamp hours isn't exactly a lot of capacity. Most of these lithium-ion cells have got over 2000 milliamp hours in them, most modern ones. Certainly the ones that you use in genuine laptop batteries. So these lithium-ion cells have come from used laptop batteries, and normally what happens with a laptop battery is perhaps one cell goes down, which leaves you with a whole bunch of cells that are actually in good shape. So what we're doing is wiring up all of these batteries in parallel and then gluing them into the enclosure in order to make one large high capacity phone battery bank. Wibble wibble, my old man's a dustman. Yeah, I'm using a temperature controlled soldering iron, and yeah, soldering to lithium-ion cells is not exactly good practice. It's a little bit dubious, if you don't mind me saying so. But in this case, we've got everything wired up and ready to go. I've soldered a lot of lithium-ion batteries in my time and haven't had a problem yet. But a lot of people like to use little spot welders to connect these lithium-ion cells together. So we're just going to go ahead and solder that bad boy up to the little charge PCB, the battery management and charge PCB, and then we're going to glue everything in place. Yes indeed, hot glue. I love hot glue. Woohoo, hot glue, yay! If you've got this far into the video, you've done really well, and what I want you to do is just repeat in the comments section, wibble wibble, my old man's a dustman. So I thought it would be quite a good idea to use the cable with a USB plug on it in order to align that little charge PCB. And what's great is that charge PCB cost me £1 from Poundland, effectively, and with it I got a free enclosure and a free little 1200 milliamp hour lithium ion cell. Maybe we can make our own little solar light out of the lithium ion cell and a tiny solar panel, and perhaps put something cool together and make the most of it. Recycle. Great news. It works. It doesn't work with the iPhone 8 and above. So because the charge PCB is a poorly designed cheap charging PCB, it doesn't have the 2.5 volts that a computer would normally send down the 2 signal lines of a USB style socket. So ultimately the iPhone 8 and iPhone 10 don't work with this system. but older iPads and older iPhones and pretty much all Android phones and most MP3 players will work with this. As always, please don't forget, this is indeed YouTube, so thumbs up tells the algorithms that we're all good and everything's sensible, and perhaps this is something slightly interesting to those people that might be slightly interested in this kind of thing. So give us a good old thumbs up, don't forget to subscribe, click the bell, and all of that madness. And a massive, massive shout out to our wonderful patrons. Cheers and beers, guys. Have a wonderful week. Cheers. Bye-bye.